welcome to Flight Test. I'm Josh, and today we're going to be showing a setup video on the Naze32, specifically on our new VersaCopter. Now, if you don't know what the VersaCopter is, we have a review video linked down below and also a build video. But in the build video, we actually featured the GR18 with a control board built in it. It's an all-in-one control board, very simple, very easy to use, but a lot of people really love the functionality and are familiar with the Naze32. So what we thought we'd do is go ahead and show both of them. Now in this video, we're also going to do something a little bit different. We're going to go over things like OneShot capable. I'm actually using Lumineer speed controllers that have OneShot auto detect. And also I'm going to talk about backing up your settings, loading settings, and speaking of PID settings, Zach from Blackbird FPV was kind enough to custom tune a VersaCopter for 4-cell operation, and he shared those PID settings with us. We're going to post those, but I'm also going to be showing you how to load those up. So if you guys are building a similar setup that we have, most likely you can load this up and have a great experience. Now there's really not much materials to get in order, so we're going to fire up our soldering iron and start right from the beginning with an Naze32. Now if you all have never soldered before, it's really important. We're going to have a link down below pointing to our soldering episode where we show you how to solder. It's very important not to have too hot of a temperature and to do this properly, or else you're going to blow out your Naze32 board. The first thing we're going to start with is going to be putting the right angle pins on here. You're going to notice that with these kits, you have lots of different pins and pin angles. For this application, we're going to be doing the right angle. Now there's two ways you can put this in. You can put this in like so, but if you did that, the connectors wouldn't go evenly. So you want the 90 degree to go through the holes, just like that. Now you can use helping hands if you want, but I found honestly that just laying it on the ground, being very careful to leave these 90 degrees, does wonders. We're going to clean our tip. And I'm just going to tack one end. This is a little bit blunt of a tip to be using. There we are. We're going to let that dry. From this point on, you can see that it's actually holding on quite nicely. Now we can go ahead and go down through and solder all our tips. I'm actually going to go on the far side and I'm going to work away and towards me. So I'm going to go to number 1 on the signal, just touch the pin. Just go right down the line. Give that just a little second. Doesn't hurt if you have a magnifying glass to give this a really good inspection. It looks good. Alright, now there's a lot of different connectors that we normally can use on this. We can put buzzers, we can put lights, we can have so many different functions on this Naze32. It's a really powerful little board and very affordable. But all I'm going to be putting on is the control board. Now because this is so small, I don't want this to break loose. So I'm actually going to plug this into here, so the pins stay in the right orientation, doesn't get too hot and melt them and turn on me. Same process as before. I'm just going to lay this in, and I'm only going to focus on tacking one down. There we are. We'll let that rest. Say we're not happy with the alignment, I can just touch this, push it right to where I want, let it dry. Before I go any further, I'm going to inspect it up nice and close. Everything's lined up really nice, and now I can go ahead and flow my solder in on both sides of the board. Okay. Put my tip here. I'm just going to check and make sure everything's flowed nice. There we are. And the last step will be to repeat the process on the other side. Alright, so after every time you solder, don't go on. Go ahead and immediately inspect over the area you just soldered. If you solder everything and then start inspecting, it's going to be a lot harder for you to pick out flaws than if you're going over just 5 joints as compared to 35 joints. So everything looks really good, nice and strong, and lined up. At this point, we're ready to program the Naze32. Now that our Naze32 is all set up, we want to tell it to operate on the clean Flite platform. Right now the Naze32 comes defaulted on its base Flite. We don't want that. We want clean Flite. Clean Flite takes advantage of OneShot, has an amazing community behind it that's always contributing knowledge. We just love those guys. So we're going to flash this right now with clean Flite. On the computer here, we've downloaded the clean Flite app. It's a Google app, so you can go to Google, you can download it. If you look down below on the links, you'll be able to find the clean Flite app and all the other links that you're going to need to get this loaded. Apple's a little funny. You do need to download a special driver for it, so just take that in mind if you use Apple. We're going to go ahead and make our connection here with our USB cable, and now we need to flash the firmware. So right on the main page here, you see the button called Firmware Flasher, and then we're going to select the Naze32 board. So from this drop-down box here, we're going to check the most recent stable version, which is back in June, and we're going to click on it. We have that. We're going to go to Load Firmware Online. There's our firmware. And now we're going to go all the way to the bottom of the page, and we're going to click Flash Firmware. This will take a little while. Make sure you don't unplug it while it's doing it. There we are. Now if we click Connect, what we should see is an image of a quadcopter. And that's exactly what we have right here. See, it's moving around. Now there's a couple special things that we're going to want to do to this before we move much further here. Different configurations, different PID loops. It's just the way the machine is tuned. There's 3 key settings that dial these in. There's different loops and different ways they operate that are well beyond me. But we have really great people out in the community like Zach from Blackbird FPV and Sharpoo and all these great people that share their PID settings and then also their motor configurations. So if they share that configuration and you have one that's close to it or matches it perfectly, you could download their PID settings and actually upload it to this. Now this is a 4-cell setup with OneShot enabled from Lumineer. We got our Emax 2204 motors, but we have the Lumineer little micro 20 amp ESCs that are OneShot auto detect. That means when I tell this to work off of OneShot, it's automatically going to detect that. That's very similar to the setup that Zach actually tuned for Alex a few weeks back when he was here. So we're going to go ahead and use that, and I'm going to show you how to actually put those settings on it right now. On this main configuration page, you're going to see a button that says Restore. We're going to click on that now. And we're also going to post these PID settings on flitetest.com/setup. So you can download this text file if you're running a similar setup as well. Right here on the main page store on my desktop, I got my little Clean Flite backup 4-cell configuration. I'm going to click Open. And when I do that, the box is going to close. And if I read closely, it says Migrating Configuration File Generated by the Configurator. That's a lot of weird words to say. Basically took the settings on the computer and it inputted them. So before we had something called a PID loop of 0, and if I go to PID loop and look at PID timing, originally it said 0. Now you can see that it actually says LuxFloat. LuxFloat is the PID loop that Zach prefers to use, and it's really an amazing PID loop. I don't know much about it, but there are some amazing people, which once again we have links down below that explain PID, what the different loops do, also on how to tune, how to diagnose, all those things. Those will be located in the links below. But now we have Zach's PID settings, we're ready to move forward a little bit more. I'm going to go to configuration right now, and as you can see this is down as a X configuration, which is exactly what we want, but the way this is going to be installed inside the board is not going to be with the arrow pointing forward. Generally when you mount the board you want the arrow always pointing forward. This is actually be rotated 270 degrees, so we can actually internally mount the Naze32 board inside of the VersaCopter. Now we need to tell it this, because otherwise what will happen is if we have the board turned and we pitch forward, it's actually reading it as a bank. We don't want that. We want this to be pitched forward and then this to be bank, and we have it backwards. So in configuration, I'm going to scroll down just a little bit, and I'm going to find something saying yaw adjustment. And in this right here, I'm going to type in 270 degrees. I'm going to scroll all the way to the bottom and hit save and reboot. There we are. So now when I go to configuration and I hit setup, go ahead and do my accelerometer calibration. If you guys ever notice that it moves real slow, set it down on the level table, hit accelerometer calibrate, and then that way it'll reread it when we're back in business. So now, as you can see, as I pitch forward and bank and yaw, we're in good shape. You could technically mount this thing vertical and backwards, and as long as you put the right offset, it would read it just fine. It gives us a lot of freedom to design really unique frames that can make it skinnier, can make it wider, can mount it in unique locations, and still have it read very well. So this is the way we want it configured. We're ready to go ahead and hook it up to our receiver that's already been bound to our radio and move forward. Alright, our next step, now that we've flashed this and also preloaded some configuration, we're going to go ahead and put this on the multi-rotor and then do the rest of our tuning with it on the multi-rotor. Now on the VersaCopter kit itself here, there's going to be an extra piece in the kit. And if you line up the little cutout gremlin with the rest of the logo this way, this is the way that we're going to want this to snap in. The reason we're doing it is so say we have to service this and pull this off, the control board will be on here, but it'll keep you from accidentally putting it upside down. So we're just going to orientate everything. But first, we want our control board on. So we're going to flip this over. Now this is just some simple double-sided foam rubber. We're actually looking at getting some of this carried in our store. It works really good. So I'm going to peel this back. I'm going to stick this little foam pad right on here. You can use 3M double-sided tape. And for this application, because this is going to be internal, build it up about 1/4 of an inch. I really, really love this foam material. It's really good with vibration. Like I said, I'm hoping to get a chunk of this to carry in the store. So that's on there. It's not going anywhere anytime soon. We're going to want this orientated in a way, when this is stuck down in here, it looks just like that. So we can access it with our USB cable. To do so, we're going to stick this about 3/8 of an inch or about 1 centimeter inward inside this frame. So when we flip this in and clip it on the tangs, it's right where we want it to be. Alright, we're happy with our mark. Peel off the back side here. Everyone has their favorite tape that they use, it doesn't really matter. And once again, we're going to go about 1 centimeter or so in. We don't want to go in the middle because it's going to be very hard to go to the other side. Right there looks about right. We're going to press that down. Let's go ahead and do a test fit real quick. There we are. Now even with this 90-degree angle on here, I can still plug this in, no problem. But it's nice and protected now, so if you have a real hard crash, everything is internal. Our next step is going to be fastening this harness. Now this is a little harness here that's included. We're going to want to take special note of the first 3 wires. The order we're going to want our first 3 wires that we're going to be working with is going to be black, red, and white. The reason why we're looking for those first 3 wires is that's going to be what identifies the way this plugs in. This can plug in both ways. We want it black, red, and white, just like here. So I'll get you a point to look really close here. If you have to pause it, go ahead. But you're going to see there's our ground. The little dot is our power, and then 1 is channel 1, 2, 3, and then on the bottom, yellow is 4, 5, 6, and then you actually go into your auxiliaries. We're not going to need these back ones here because I only have a 6-channel radio I'm going to be operating. And if you want, I'm going to show you a quick little tip before we move much further on how to remove those. So these 2 last wires we don't need. And rather than having them laying around, we're going to just go ahead and take them off. You could cut them, but if you cut them, you have a chance of a frayed wire giving you problems. We're actually going to remove them. Alright, I'm going to put some real gentle pressure with my fingers and take my fingers, I'm going to push away the connector. I'm going to take a little razor blade, pop underneath here, and slide out the white one. Do the exact same process with the red one. So once we lift this up, now I can put a little bit of pressure on it and pop it out. Save these for later. Say you have a cut or you reach in here or one of these gets fatigued, you can always replace these now in the future. They also work really good in the future for other signal wires or making solder leads or tracer wires. Alright, let's go ahead and reinstall this. There we are. Now we really prefer to use Graupner. We're really enjoying the functionality of it. This is just a simple little 6-channel radio, full range. It does not have diversity on it, so we're going to want to make sure when we place this antenna, it's up loud and proud above all the other plates. So we're going to want to orientate this really properly. If you have diversity, it's really nice because you can angle it 90 degrees and have good control every which way. This has the exact same pinout as the Spectrum. So we're going to look at the Graupner radio right now. And we're going to look for our ground in channel 1. That's where this is going to go. So we're going to plug channel 1 with the ground facing up. If you ever wonder what these pictures are, the minus is negative or ground, the positive is your power, and then 1, 2, 3, 4, or sometimes you look at something that looks like a little horseshoe, that's your signal. So this is channel number 1, signal wire is on the very bottom, channel number 2, signal wire on the bottom, and so on. Sometimes you'll see it labeled throttle, aileron, and it'll just have a little horseshoe. The signal wire, or oftentimes like the, I guess you could say the odd color wire, will oftentimes be your signal. Alright, the rest of these are actually only single wires, and I'm going to go to the next one, which is going to be brown, and I'm going to plug that into 2. Now, as I mentioned before, this is already bound to my radio. If you have it bound, I'd strongly recommend that you bind it ahead of time so you're not trying to get bind features to work while powering your control board. I know some things like Spectrum and stuff, they don't like that. Okay, channel 3 is the green wire, all the way on the very end. Now we're going to go all the way back underneath our black wire, and we're going to grab this yellow wire. That's actually channel number 4. Press that in. Now we're going to look for channel number 5, which is going to be the orange wire. And this is going to be my racer setup. I'm going to be racing this and learning how to race, and probably learning how to crash a lot too. So I'm not going to use the other 2 functions, but if I want to do something like auto tuning, or I want to do horizon mode, there's a lot of really great features. Arming, so I could have channel 5 be my arming and channel 6 be my different modes like horizon, angle, things like that. And Naze32 has or CleanFlite has a really nice setup that lets you configure this, and you can configure it later on down the line. You don't have to do it right now. So all my channels are now filled, and I'm ready to install this. So we got this mounted, we got a receiver done, it's already bound, life is good. Our next step is to connect the proper ESCs, and the easiest way to tell, don't ever take it for granted, is to plug this in, let it connect. There we are. Okay, we'll let it connect, and now we're going to go to configuration. The reason I wanted to go to configuration here is you're going to see your video, the layout of motor 1, 2, 3, and 4. Now don't assume every platform is like this. Grapner is actually in a different order. Grapner is actually 1, 2, 3, 4, or something similar to that. So always check as a new version comes on. They may change the order of which motors are plugged in where. So I go to this screen here, and now keep in mind that we're looking at the bottom here and the bottom of the multi-rotor. So the bottom left is actually the back right, if you look at it just like here. So just to make my life a little bit easier, I'm going to go ahead and I'm going to switch this to the right orientation. Now on this, pin 1 is closest to the arrow. That's going to be our number 1 signal wire, so we're going to plug in signal 1, 2, 3, and 4. Motor 1 being the bottom right, we're going to grab the bottom right. So I'm going to make sure our white wire is the wire I plug it into, just like that. Now we're going to see number 2, it's the front right. You can see that my props are off. It's really important that we do that. Back left, there's our back left. And at this point now I can flip it over because I think we got a good pattern going on. There's only one left. And there we are. Alright, so motor 1, 2, 3, and 4, starting from the arrow, work in this direction. So we have everything plugged in. Motor number 1, motor number 2, motor number 3, and motor number 4. As far as the orientation and which direction they're spinning, we're going to go ahead and check that out after we get everything buttoned up. So I'm going to unplug this. And let's go ahead and dress our wires and get this done. Once again, we have our little gremlin here. It's in the same configuration. In this case here, you could actually move this around in the front. You could do it any way you want. Just do it in a way that makes sure your wires aren't pinched and that you can access everything and that nothing's banging up against your control board. In this case, I'm going to get a little creative here. Because I want my antenna to be as long as possible, I'm going to go ahead and route this receiver. I'm going to put it on end all the way in the back here. So I'm just going to put a gentle curve and tuck the extra wire underneath. We'll lock it down. There we are. Alright. Now my antenna is nice and long. I actually have an antenna tube laying around here somewhere. We're going to put that on to make sure it doesn't hit the props anytime soon. So what I want to do now here is everything's connected. I got my video transmitter already pre-connected to a JST. I soldered to my auxiliary port. Everything is ready to be buttoned up. We can now do the rest of the settings with this external. Let's make sure that our little USB connector is not intruded on and it's nice and clear. Everything looks really, really nice. So let's go ahead and put the top panel on. Just going to grab a couple of these lock nuts here. Before we go ahead and fly, we're going to tighten down everything nice and tight. I'm going to show you a little trick here. If you're flying a 4-cell setup, a lot of power, how to lock your booms down a little bit more. Right now it's held by friction. So if you hit a real hard crash, it'll spin. But if you have real high torque motors on a 4-cell, we can actually put a little drop of glue in a key location that'll keep them there until they break away. All right, there we go. All right, at this moment, we're going to go ahead and reconnect our system. We're also going to go ahead and apply power to the whole unit. So I'm going to plug this in, just as we've done many times before. We'll hit connect. Now we can go ahead and move forward and calibrate this using our radio as well. First thing we want to do, we've done it a couple times, but we're going to do it legitimately. This is on a nice flat surface, not going anywhere. We're going to hit Calibrate Accelerometer. We're going to wait till it's done, it's finished. Now you can see we have our nice control. We're also going to double check, make sure our orientation that we haven't put the board backwards. There we go, we're pitching backwards. You can see the arrows to the front, pitching forward, rotate right, rotate left. Exactly how we want it. And obviously our yaw is correct as well too. Alright, the next step we want to do is we're going to go ahead and go over to our receiver. Now we haven't applied power yet, we're going to make sure our props are off and we're going to connect this to a battery and lock it down. Turn on my radio. Once again, it's already been bound. If you haven't bound it yet, make sure it's bound. There we are. It has a telemetry link, so it's not going to be happy until I plug it in. There we are. We now have control. So there's a couple key things we want to do. We want to make sure that all of our control signals are the right way. And if you look here, I'm moving my aileron and my pitch is moving. We don't want that, but if you go down to channel mapping, you're going to notice that this is actually mapped for a Futaba. We want to click on channel mapping. We want to move this to JR Spectrum Grapner. And then every time we make a change, always go down and hit save. You can immediately see that all of the settings just changed. So now when I go to my roll, my pitch, my yaw, and my throttle, they're all correct. Now on Grapner and Spectrum, we want to make sure when we give right input, that right input goes. So you can see when I give right input, it actually goes to the left. Same with the rudder. Right input goes to the left. We want to go into our settings and we want to reverse on this one, both rudder and aileron. If we pitch forward, pitching forward goes forward. If you look at here, when you pitch, your pulse width should go up. Pull back, it should go down. Same with throttle. When you give full throttle, the number should go up. When you pull back, it should go down. So aileron and rudder on this system is all that needs reversed. Let's go ahead and do that now. I'm going into my settings. I'm going to reverse my aileron, and I'm going to reverse my rudder. So now when I check this out, you can see right is right, left is left, right is right, left is left. You can see I disarmed it. So we know that works too. We're really happy with that way that works. I don't need to assign any of my channel mapping my gear switch, but if I did, you can see that this is working right here. We're not going to worry about those right now at this moment, but at least we have that functionality if we need so. Our next step that we want to do is we want to calibrate our ESCs, and also we want to enable OneShot. So let's go ahead and enable OneShot. We're going to configuration, and we're going to click OneShot right here. Once we enable OneShot, we want to save it. There we go. And it's done. But now we need to calibrate our ESCs, and we're going to do that right now. I'm going to unplug this and turn off my radio. Now, oftentimes the ESCs have to go above 1900 before they go into calibration mode. If you look on our configuration page, you're going to see that the maximum throttle is set at 1850. I'm going to go ahead and bump that up to 1905. I'm also going to move minimum throttle from 1150 down to 1130 and see if that's enough. When I accidentally armed it a second ago, I noticed that the RPMs was quite high, and I don't want it that high, so when I give it and arm it, it doesn't start getting real floaty on us. You want this when it lands to not have enough power to bounce up, and we'll talk about that later when we fly it. Alright, so we're going to go over to our motors now. And this is where we're going to do our Esc calibration. To do our Esc calibration, please, please, please make sure you have no props on them playing. If you have them on and you've gone this far, shame on you. We can show you pictures of Alex's thumb, but trust me, it was really gross. So we're going to click I understand that we don't have propellers on and that we're not going to hold anyone liable. And we're going to move our master all the way up to the very top. There we are, just like that. Now we're going to go ahead and plug this in, and we're going to hear 2 beeps. There we are. Now if I slide this up, you can see all the motors start exactly at the same time. That's exactly what we want. You can hear the response is incredibly quick. While we're at this page and we're turning on our motors, let's go ahead and make sure each motor is firing on the right orientation. In other words, motor 1, motor 2, motor 3, and motor 4 are operating, but also that they're spinning in the right direction. And if you look at the very top here, they're so gracious to give us the configuration page once again. So we're going to go ahead and move to motor 1. We're going to slide it up. You can see immediately motor 1 is actually running the right way. So rear right, and we want this to turn clockwise. So when we run this up, we have a clockwise rotation. That's perfect. Now if it wasn't perfect, we would take 2 of these wires and we'd switch them. We're going to go to motor 2 now. Motor 2 is going, and we're correct as well too. If you don't want to put your finger on here, you can always go ahead and put a little piece of tape. Motor 3. Just by pulsing just a little bit, you can oftentimes also see which way it's going. Excellent. And then motor 4. And that's perfect as well too. Okay, we're happy with this. We're ready to move on to the next step. All right, in full transparency, I screwed up big time. I've been going through and I've had this powered on for about 5 minutes now, and I've had no antenna on my video transmitter, and I plugged it in internally to the board with a JSD connector, which means I could have easily blown out my board. Now this is a little Lumineer 600 milliwatt, way overpowered, but with 5 minutes of it being powered on, it's still alive and kicking very well. Don't do this. And a matter of fact, if you want to do field service and you don't want this big antenna, Video Aerial Systems, that's IB Crazy's site, sells these awesome little shunts here that gives you the ability to screw it on. It doesn't fire your transmitter, and you can work on it in very low power setting so you don't shoot anyone else down within a couple feet of you. So I got the antenna on now. We're going to go ahead and move forward. All of our motors work fantastic. I checked out the video signal. That works out good too. And now it's time to go ahead and make sure that our transmitter is arming and they're going the right direction. All right, so I'm going to power on my transmitter. Power on my controls. Now if I wanted to actually set up modes, I'm not going to do it right now, but if I wanted to set up modes, I could click on here and I could add things like ARM. I'll just show you really quick here. And I could put ARM on auxiliary 1. So when I move my auxiliary 1, I can make this be my ARM switch. Now you can see it's not doing anything right now because I haven't hit save. But say I want forward to be my ARM switch, or I want everything to work on one switch, where I want it to go from ARM to horizon mode. You can do that. All you need to do is move these sliders back and forth to meet your channel. I'm happy within that channel right there. I'm going to hit save. And you can see now, with a flip of a switch, I can arm it. Now a lot of people say that's very dangerous, it's scary. I'm going to go half throttle, I'm going to arm this. It doesn't arm. It doesn't arm until it recognizes a certain PWM low. Taking away my arm. Once again, you can be full throttle, bump this, be working. The only time it's going to arm is when you slowly go down. Nice safety feature. Now, if you weren't going to use this feature, it would be down all the way to the right. And a lot of people are going to use that. People may only have a 4-channel radio. So I'm going to go ahead and get rid of this. And I'm going to hit save. Now I'm back to the old school method. I'm going to go to my receiver channel just to show you what I'm talking about. If I go all the way down to my lowest right setting, it just crossed over 1900. And when it does that, it arms it. Down to the left arms it. Now, for some reason, if you can't get it to arm, 2 things could be going on. You may have not low enough throttle setting, so what you want to do is lower your throttle. If the throttle setting was too high, it won't arm for you. So that's one reason it won't arm. So one thing will happen is a lot of people just increase their rudder to the maximum so they can get enough of the threshold to activate it. But what will happen is if you do that too high, I'll show you a symptom here. I kick my rates way up on my travel, and you can see when I move it all the way over, it bounces back. Now this would be in disarm, so imagine that you were able to get it armed, but your travel was so heavy on the one side you couldn't disarm it. That'd be a very bad safety issue. So make sure that when you peg your controllers, that, see, I couldn't disarm it right there. There we go, go nice and slow. Make sure that you have full motion when you pin the stick, it doesn't bounce back to zero. I think that's basically saying it's out of its parameters, it can't recognize it, I'm going back to neutral. One other thing that we're going to do that you don't have to necessarily do, but I found it makes the flight a lot smoother, is we're not using auto level here. So I'm going to go to my sensors, and I'm going to turn off my accelerometer. Turning off the accelerometer is going to take a lot of the board fighting against what you're doing. It's always monitoring it, and I'm not smart enough to talk about this intelligently, but what I noticed here when I turned the accelerometer off, it kind of went back to the old school days where there was no accelerometers. The flight performance was very, very smooth. So now I have this accelerometer turned off. What it'll do is it'll ignore that sensor completely. I don't know if it gives the sensor more speed or what, but wow, what a difference. If you're doing obviously self-leveling, things like that, you're not going to want to do this step. I'm going to unplug our connector here. I'm going to go ahead and rearm it. And if I give throttle on the back, I got speed going up. Right throttle, these two are ironing up. Left throttle, left rudder, this is speeding up. All of our controls are working properly. Disarm it. At this point, everything is working properly. We have the proper control signal, the right motors, we have the right spinning orientation. We just need now to put our FPV gear on, finish buttoning up, tighten everything, and we're going to do that right now. All right. We want to keep our antenna nice and safe, so this is just some RC car antenna tube. We're going to sit this down in. Now the props won't hit it. So I'm going to go ahead and add an optional AP plate here. This is actually the same small AP plate that's found on our short and long AP rails, but we also sized it to fit the VersaCopter very nicely. You can also purchase standoffs and top mount this like Alex has it, where you can undersling a board camera and put a Mobius or a GoPro on the top. You can mount on the bottom, you can offset it, you can even put bobbins on it. So this can have multiple configurations in multiple directions. It can mount on bobbins here, here. It can be standoffs here, here. It can be standoffs on the bottom here, here. Or you can do any combination of the in between. You can also flip this around if you want, stand it off, have your board camera in between with the long standoffs, and you have a cutout here so you can actually angle the camera upward when you're flying very fast forward. In this case, we're going to do the most simple one, also the cheapest one. We're going to mount it right on the bottom. Just going to get everything finger tight. We're going to put all the lock nuts on the bottom. Now, in our standoff kit, if you do want your battery slung on the bottom, there's so many different configurations you can do. But you can actually, rather than putting these lock nuts on, the standoffs will thread right on. They're 3mm screws, and you can put little feet on there. There's even little plastic screws that tap into the standoffs for your feet. So the imagination is really the only thing inhibiting you here. You can reconfigure this any which way you want. So we have 2 more screws included in the kit. I'm going to carefully pass these through from the top to the bottom. I'm going to be careful not to try to drive it through any wires. So if you have to, wiggle it around until it passes through with nothing pinching. There we are. Alright, let's put our last 2 nuts down. Now I already have this plate set up here, but I want to show you what I've done here. So one thing I've already done to this plate here is I actually glued a Velcro strap down and followed up with just a simple piece of rubber right here. Now you can obviously offset this with bobbins on the top or the bottom, it's up to you. But what I like to do is keeping this as sleek and simple as possible. Now, flying 3-cell, flying slow, things, not close to things, flying through the GoPro is just fine, and I actually do it quite often. But if you're going to be flying close proximity, you're going to be shooting through trees, and you need 0 latency, I strongly recommend plugging into a board camera. Now you could easily mount the board camera right over top like this. The only difference, instead of tapping into your GoPro, you're going to wire this up to tap into here. Now be careful, not all board cameras can go up beyond 3 cells. Make sure you look at your specifications before you order, and if you don't have a camera that can go beyond 3 cells, solder in a Palolo board that has a 12-volt regulator in it, and you're good to go. So in this case, if I was going to fly through a board camera, I would mount it just like you see here, and be good to go. I could change my angle any angle I want, independently from each other. For this, we're just going to keep it simple and we're going to go from here. So I got my little GoPro strapped in. I'm going to plug in my little cable. And now it's time to fasten down our frame and tighten all the nuts and the screws and make sure everything's true. Alright, so I got my 2 screwdrivers here. I got a socket set and a 2mm. If you guys buy the E-Pack, it comes with the 2mm. This socket set is only currently available through our long rail system, but we're going to look very soon to carry it separately. So if you're watching this video, check out the store if you don't have any simple tools like this. They're very handy. Alright, so this has already been evenly spaced and kind of friction fit, so we're good to go. If you're really wondering, you want to eyeball it, put the props on temporarily, and shift the booms back and forth until it's nice and even. But right now it's perfect. We're going to go ahead and fasten this down. Now you don't want this to be so tight that it's cracking everything. You want this to be nice and snug. The biggest way to determine if it's tight enough is, are the booms tight? This is the earliest version of this. We're looking forward to learning and seeing how mixing carbon fiber tubes into our design is going to work. So don't be surprised if you see some new versions in the future, or different things made out of different materials. It's all going to have the same principle. These back bolts and the very front bolts are what tightens down the dowel ring clamps over the carbon fiber booms. So don't over tighten it, but at the same time make sure it's nice and snug. We're going to go back and we're going to actually give a twist test to all this, make sure everything's fastened. So that's down. I'm going to grab this boom. I'm going to try to twist it. And it's good. Now the only thing right now moving is this out, and it takes quite a bit of force. I'm going to lay this flat on the table just like you see here, and I'm going to push down hard against the table, and that's going to ensure that everything is nice and flat. I'll go back here, and I'm going to keep an eye on my booms, make sure I'm not turning my whole boom at a slight angle. If I turn my whole boom at a slight angle, this isn't very tight, and I want to hold these down together. Alright, everything's nice and flat. We made sure we Loctited all these going into the motors. Feels good, nothing loose. Alright, let's go ahead and put our props on. Alright, as far as the orientation goes, with this multi-rotor here, the props all spin inwards. So if you're looking forward here, the props are going to spin in towards the center. And the same as the back, the props are going to spin in towards the center from the back. Let's generate and lift when it spins in towards the center. If you guys are wondering what the silver and the black prop nuts are for, those will indicate whether it's reverse thread or standard thread. Now in the future we're probably going to move to all standard thread, but the reason why you have reverse thread is for reverse props, the torque of the motor keeps the prop nut tightened. If it's the opposite and it comes slightly loose, it'll spin off on you. Now if that's happened to you in the past, these are very difficult to find. If you go to our store, we have custom spun CNC'd aluminum lock nuts that have a shorter shelf, so the nylon lock ring will grip onto them really tightly. And then God forbid if you get in a crash and it kicks it, it'll just take the loosen up enough to take the torque away from the prop, and then it'll just spin freely. It's also a lot cheaper than trying to buy a whole new motor. So here's this, here's our reverse. So instead of righty-tighty, it's lefty-tighty. It doesn't rhyme at all, it's terrible. Now it's very important when you're installing your props, if you see something that looks like this in your kit, that means it's not a precision prop, that you have to put these little spacer rings on before you put this down, and this is a precision piece here. You can see too loose, too tight, just right. So simply take that, crack it, seat it all the way down the bottom, and then your prop will slide right over top of it. That'll take it no wiggle. If you can wiggle your props back and forth on the shaft, you need a spacer. Now, once you put the props on, it's getting real. You want to be really careful on what you do from this point on. Don't just plug it in. Don't mess with your controls. If there's any questions you have, whether it be, did I plug this in, did I fasten this right, just go back and take your props off. It's not worth cutting your hands. And although these are very small motors, they have a tremendous amount of power and RPM behind them, and they can do a lot of damage. Alright, let's go ahead and tighten these down. There we are. Confirm. Generate and lift while it's spinning in. Generate and lift while it's spinning in. And none of the wires are getting hit. And then I'm going to follow up with a little drop of CA inside the open cracks and let that flow. Delrin's very fatty and CA doesn't glue to it, but what it does glue nicely to is carbon fiber. And by putting it in the cracks, you're going to make a little tiny key of glue. And under a hard impact, it'll break loose. But under general flying, it's going to stay nice and firm. At this point, all the nuts are fastened, everything's secured down, we're ready to go out and maiden it. All right, we're all set to fly, and one thing I want to encourage you is if you have any concerns, any questions in your mind, go back and check it. Take off your props. This is not something like an airplane where if it's not just right, yeah, it'll probably still fly. If something's backwards, like your gyros, your controls, your props, it'll cause a lot of damage to either the multi-rotor and yourself. We want you to be safe. In this case, I'm feeling confident about this. Our video link is strong, but you can see I'm not test flying it with FPV goggles. We want to make sure that it hovers, it flies, all the controls are doing the right thing. So I got a nice flat level surface. Let's go ahead and power it up and see if it flies. Arming. Nice. My bank's right, my pitch is right, my yaw's right, and the power is good. Now once again, Zach from Blackbird FPV is the one that tuned this. He has a lot of great setups, and I'm at a third throttle. All right, I am really happy with this. Let's go ahead and land it, put the goggles on, and have some fun. Now, one reason why we're doing this video separate is our ESCs are BL Heli. BL Heli is capable of OneShot, and the newest version we have coming out will have auto detect on that. Today is September 22nd, 2015. I want to date stamp this for a reason. Before you order any electronics from us, if you want something that's auto shot capable, make sure it'll be labeled down below on our e-pack, auto shot capable. If you don't see that, that's the older stock. We don't have that technology yet. Lumineer has that now, and we're going to be quickly upgrading in the very near future. But I don't want to sell you something that's not capable of. All of our ESCs are capable to be flashed up to be able to receive OneShot, but that's a video in the future. I want to make it easy just to go along with this video. All right, let's put our goggles on and have some fun. Arming. Here we go. Oh my gosh, this is a blast. So I'm new to FPV racing in the whole world, but it wasn't until I got this set up here that I felt truly free to really experiment and push the limits. This is not something I would jump into right off the bat. I would strongly recommend learning off of 3-cell and going with a tame setup, but once you're ready, a mod like this and just reconfiguring your electronics is only a couple hours, and it's incredibly smooth. And the power is just ridiculous. All right. Now, one thing I strongly recommend is make sure, right now we're just test flying it, so I'm not going to take it up too long. Make sure you have a voltage alarm fastened to your battery. Multi-rotors don't glide. There we are. Friends, I want to thank you for watching. This setup is great right out of the box. Now, if you have a slightly different setup, you can start with this. If you have a 4-cell operation, OneShot, we're running our stock 2204 motors on a 645 prop with 4-cell. They're not even getting warm. But look for upgraded kits, and also Lumineer, who kind of helped us along with this project, who helped us draw the board, also has an amazing power setup that gives you the ability to fly even faster and harder than what you see here. All right, if you're watching this, it's all available in the store, and we'll see you next time.